Yes.
All right, so welcome to CSC 410. I'm excited because we intend to host in-person classes this semester. And there are a few hardware challenges in the classroom where we're going to set up shop on St. Croix. The instructional technology was, it's in need of some additional components, but that should be in place by this next Tuesday. And I'm working on that now. So for today and Thursday, we'll join by Zoom. Can everybody see the screen comfortably, or do I need to enlarge?
It's good.
Okay. So as you know, this is considered one of the capstone courses. It's a 400 level course for computer science majors, and the emphasis is on OS internals. So in case you've had me in a course for operating systems previously, if it was 200 level, if it was 255, that was about deploying and maintaining and configuring operating systems. But in this course, we want to dive deeper and get under the hood into the kernel. We want to talk about design principles so that you understand how to build an operating system. And there may be opportunities in the last module for you to customize certain Linux distributions by tuning the kernel. The term of record is called tuning. So you tune the kernel by customizing it. On the Windows side, this process is effectively implemented with digitally signed low-level hardware drivers. So these are very low-level hardware component drivers. And there are aspects of the operating system kernel that change. We're going to work primarily out of Blackboard, as we have in previous courses, but we do want to work a lot of hands-on. And one of the things we'll do early on in the course is assess how your own technology is suited to conduct some of the hands-on solutions. So tell me, were you in classes with me when we were working solutions?
Are you talking about any solution or like a particular class?
Well, any of the classes where we had module solutions?
Yeah, I believe so.
Okay.
Yeah.
And how about virtual machines? Has anyone?
Yeah.
Okay, so that would be a relatively new thing. Last year, we had some virtual systems for remote use by students. And that's something we're going to do again this season. And in particular, we're going to interact between virtual machines on your own technology and virtual systems in the cloud. I did want to take a little bit of time to walk through some specifics. You know, you call this housekeeping chores, but you'll find that the syllabus and the information in Zoom links are all here in these handy links. And so you don't have to go digging for Zoom links, right? There's always a Zoom link to start the session here. And I will be working with the whole class video camera and microphone, so that if you just want to come to class in person, that's fine. Is everyone familiar with the classroom over on St. Thomas? For the two of you that are on St. Thomas? It's a CA building, right?
Is it gonna be CA? Yeah, the CA building.
Right. Now I was told yesterday that CA 101 was out of commission. But that a number of the classes I teach for St. Thomas students would work out of CAB 103, and I told them to send me an update so the classroom for St. Thomas, though, for this course is the Teaching Education Building 101.
Oh, okay.
Yeah, that's a little different.
Yeah, it is.
Yeah. And here you see 101 and 112, and I think they're in the process of reassigning those classrooms. So what I'll do is plan to get over to St. Thomas in the next week, and I'd like to set up physically in teacher education, right? And 101, and I need either or both of you, Tommy and Deanna, to be comfortable to sign in on that system so that you can basically be my proxy in the physical classroom. Now, if it's just easier to work with laptop screens and you'd rather be home in your bunny slippers, that's okay too. But I do plan to teach classes in person, and I do want to do it live from St. Thomas, from this classroom, at least once a month and hopefully twice a month, right? I'd like to be over a lot more frequently. You'll notice that the enrollment is small right now, and it may change, or it may not. We have a number of senior qualified computer science students who are sorting some things out with their work schedule. But I wanted to assure all three of you that because this is a capstone course, we will maintain the course even though there's a lower enrollment, because it's required for your graduation. So I don't want anybody worrying about whether or not we're going to continue with the class, or whether it's going to be delivered in a hybrid format of instruction. So even if you can't make it in person, we'll still carry the screens in Zoom, we'll still record them, and we'll still post them online. Any questions at this point?
None right now.
Okay. How about you, Shanoa?
No questions.
Okay. I will stop talking at one point, and I would like, you'll notice that ordinarily the class runs 75 minutes from 11 to 12:15. And what I'd like to propose is that when we get started on Thursday, we'll run about 35 minutes, 35 minutes. We'll take a 5 to 10 minute break, and then we'll run another 30 to 35 minutes. And then that way we'll have classes in like 2 halves. And so why am I telling you this? In case you joined the session late, or in case we have a late start. I mean, today is an exception, and it's not something we plan to repeat ever, if possible, because things are different now. But what we'd like to do is break the class down into 2 halves, where we run hard for 30 minutes or so, and then we take a short break and run hard again. If you're joining us 30 minutes into the class and you notice, wow, you can see, and I'll do this, I'll capture this here. You can see from the participants list that people are supposed to be in there, but it seems like things are dead. I'll try to remember to post a quick chat or a notice in chat that says, yeah, we're taking a short 5-minute break and we're resuming at 11:40, right? Any questions about how we're working each session? I want to apologize in advance. All right, so I do have updated information here. And I think Shanoa, you may be the only one I don't have a cell phone number for. But what I'd like to do is also beam text messages. Sometimes there's a delay with email delivery. If you were used to emailing t.kentop@iCloud, I'm not working with an iPhone anymore. I'm working with Android devices. So I have an LG, basically an LG Chrome-based phone. And I've got a Gmail account there. So I'm going to be using this instead of the iCloud. If you have contact information from me for my personal email, my cell phone number has not changed. It's still a Charleston, South Carolina area code. So as long as you have US dialing, you can hit my phone direct. But if you're in a hurry or you need to get my attention, you can send a 911 text message. So what you do is start the message with 911, and that tells me, oh, this is important. And no matter what I'm doing, if I'm in a meeting or I'm advising, and ordinarily I'd have my personal technology set to stun so it doesn't interrupt the class or whatever. I'll stop a moment and I'll pause, and then that way, if you're trying to give me a heads up about something that's urgent, you'll get through a lot faster that way. I've also found out that sometimes text messages don't go through right away, but voice calls do. So if you send a text message and it's urgent and you say 911, and basically you don't get a response after you send a second one that says hello question mark, hey, are you there? Hello question mark. Call. Just call directly if you can. And for some reason, the phones, I'm with Verizon service. I don't know if the rest of you use Verizon. I'm guessing most of you use Liberty, which used to be AT&T, or T-Mobile, or something else. But I'm pretty sure very few of my students use Verizon. Are any of you on Verizon service with your cell phone?
No.
Okay. Well, since Liberty took over, there was a contract agreement between Verizon to carry dial tone for Verizon phones in the territory with AT&T. And I don't know if that's going to evaporate at the end of the calendar year, or there might be a change. But in any case, if we start to experience problems, I just wanted you to know that's one way to reach me. I will be around the office quite a bit, and I do have a healthy schedule. So I'll be in person on campus from 10 through 2 p.m. on Monday, Wednesday, and Fridays. And I'll be in campus from 11 to nearly 4:30 on Tuesdays and Thursdays. Thursdays are the only day that's harder to catch, but I tried to arrange my office hours so that there would be morning hours and afternoon hours on alternating days so that folks could get a hold of me. But I do ask for your cell phone number, and I promise not to pass it along to other people unless you call me on any day after 10 p.m. At which point I'm gonna get in trouble with my family, and at that point anything's fair game. So if you might have something that's really urgent, but I do ask folks to and I kind of joke about it. I wouldn't put stuff about your cell phone number on the dark web, but but I'd make sure that you were bugged just as much as I am. by phone calls after 10 p.m. And for some reason, those have been more frequent in recent days. I'm not sure why, but yeah. Any questions about how to reach me and accessibility and availability? Now, I've spent more time covering this in our introductory session, in part because if you're using a virtual machine and you're using it after hours, this is a practical part of the logistics of our course. You may or may not use your own personal technology to run many activities with the OS solutions. You may choose to use the virtual machines exclusively instead. And you'll notice that my office hours are pretty tightly clustered. So you may be working on your virtual machine in the morning or in the afternoon or in the early evening, and you might need some reset or support for the virtual machine. And I want you to feel comfortable doing that, just not after 10 p.m. Okay. Now, what do you do if there's a deadline for submission and it's 9:30 and your virtual machine access has crashed and you're not sure if it's the network? And what do you do in that case? Then send a 911 text message that says, you know, here's a screenshot of the access that dropped. Due to access limitations, you know, can I extend, you know, can we extend the deadline for 24 hours or so? In which case, I'll always support that. So I'm available into the early evening, but there is a hard cutoff at 10 p.m. Don't let that stop you from working anytime it's convenient for you. But if you need support for the virtual machines, just be sure to capture screens. Everybody here knows how to do a screen capture, yes? In any variety of ways? Okay. Romy, you remember how to do that kind of stuff, right? So looks like Romy's dropped. What we're going to do at this point is get started with just some initial concepts. And I did want to call your attention to the milestones that need to be completed into the early part of September. And I may have mentioned this in previous classes, but if they're ordered in a certain sequence, it's really important to complete the activities in that sequence. So the first two assignments, then the article summary, and then the solution before you hit the assessment. There will be concepts that are covered in the assignments and the solution that may present as assessment items. Oh, there's Tommy. He's back again. So yeah, there may be concepts or methods that appear in the assessment, and you're going to want to complete these in order. I know that an online format tends to be really flexible, but I'd encourage you not to like jump to the big stuff first before the lesser assignments are covered. There is an alternate, and I wanted to mention this in the syllabus. So for many years, we had a different textbook, and I was a little frustrated with the traditional computer science textbook for operating systems because it was really a legacy reference, and it was written by Silberschatz, and there are some other pioneers in the operating system arena that they're going to be household names very shortly. And Silberschatz is one of them. And when you click on this, it was kind of a joke to me. Now I'm gonna, you know what, I'm gonna fix this right here. I want to make sure that this is actually hitting like it's supposed to. If you find any links that do the same thing, please let me know. So I'll take this link right here, and then run up to this screen, and I think that should fix it. And actually, the pop-up should read the same here. Sometimes when you paste from PDFs, it doesn't do the same thing. So let's try this again. Can everybody see the dinosaur?
Yes.
And can everybody see what edition we're dealing with?
Yeah, the 10th.
Yeah, so this is really a reference that was revered and honored for decades. This is, I mean, we're dealing with people who have been in the mix for operating system publications for over 30 years, right? And when I first arrived at the campus, I said, yeah, this is a great reference, except it's kind of dated, right? And at the time it was, and then they came out with the 9th edition, and now the 10th edition includes some new information. It's really more relevant. And so we flip back to this. There is a separate reference that I use frequently, and it's free. And I want to share this with you. It's called 3 Easy Pieces, and operating system in 3 easy pieces. And as you look at our first set of module objectives, everybody remembers you click the header to get inside this, yeah? To get into the references and such, yeah?
Yeah.
Okay,
Yep.
and there's your yeah, there's the module study guide, and we'll have addendum and so on. 3 easy pieces. So if you Google OSTEP, the term OSTEP, and OSTEP, and ARPASI, do so, I think. OSTEP, operating systems in 3 easy pieces. There is an open source version of this textbook. You can buy it electronically. And why do you care? Why would you worry about buying or using a separate textbook? Well, these 2 instructors are also legacy faculty from the University of Wisconsin at Madison. And University of Wisconsin at Madison is known as a powerhouse for engineering. So when it comes to technology engineering disciplines, they've always been very highly reviewed, much like UC Berkeley and MIT and Carnegie Mellon, right? So the thing I like about this is that there's a free copy, version 1.0, and it includes the same chapters that you get from the book, but you can get online electronic copies for like $10, right? So this is kind of a best of both worlds phenomenon. And every now and then I'm going to ask you to read things out of this book, because it's rich and short, and it's an acquired taste, but you'll get things out of this book you'll never see anywhere else. A good example of something like this, has anybody ever dabbled with C or Unix? So Kernighan and Ritchie were the 2 powerhouses that worked for Bell, AT&T, in the late 60s, and they developed the first components of the C programming language. And then shortly afterwards, they took up development for the first Unix operating system. So the programming language C was authored in part by Kernighan and Ritchie. It's a short book like this. So it's the kind of book where you read it and then you have to read it again, and you're not sure exactly what they're saying, but then you do a little research on your own. And then when when the light bulb finally comes on, you're like, wow, this is amazing. And it's not the kind of stuff you can find anywhere. When you get online and you search for OS concepts, you have to beware. There's a lot of armchair experts that throw a lot of incorrect concepts around, but this is a gem. This is a hidden gem. I do want you to purchase the dinosaur book, just the same, or rent the dinosaur book. So you can rent it for $29, right? Either textbook, if you buy it outright, is suitable as a lifetime reference. So there are some textbooks, and I've said this in other classes, if I go to the trouble to identify a textbook and I commit to it, it's going to be affordable, but more importantly, it's going to be affordable for you to own, because when you buy it, you're going to use it and come back to it. If you work in this discipline, if you continue advanced studies in this discipline, you're going to have to find stuff that's credible, and you can't always find it with a Google search. In fact, one of the worst things you can do is get out there on GitHub or in some online, online references. And there are a lot of experts who are basically misinformed. And there's a lot of mistakes on the kernel level that create all kinds of havoc. Now, when we talk about kernel level, one thing I'd like to do is spend a moment in here. And let's just pull this up. So essentially, I'm looking for one diagram here. And this isn't the one. So I'm also going to pull in these Kernighan and Ritchie references for the operating system. And those will also, or should also, be posted here. Let's see. Let's go back. So I also have slides from, not Kernighan and Ritchie, 3 Easy Pieces. And so what I want you to do is to spend some time digging in here. And there is a, let's see if it's in here. Notes and diagrams. This is probably it. Yeah, this is probably it. Yep, this is the one. Quick diagram. Can everybody see the screen?
Yeah.
All right, so at the heart of it, an operating system makes the entire realm of technology possible, because we have so many different flavors of hardware. When you think about Windows laptops and PCs, or you think about Android devices, there are so many types and brands and models, and they're all built differently. So there's this cacophony of devices that are all engineered in different ways. And then at the top of this, at the very top of the technology challenge, are applications and software that are being developed so that the real human being, the top layer itself, the users, right? So users could be up here, and users don't appear on this diagram, but in terms of the pure technology, just the technology layers, not the human beings, you have software and applications that have to work, whether you're using an LG phone or a Samsung phone or an iPhone or a Windows laptop. And so all of these different hardware platforms are different. And the OS, the purpose of an OS, a lot of times the word firmware is used instead of or in place of the term operating system, is to serve as a universal translator for low-level assembly language or low-level hardware calls, right? So as the application or software is working with resources, you know, memory and disk space and executing statements, it has to make use of different types of RAM modules, different types of CPU registers, different types of hard drives. And in order to account for that on this level, no computer science professional would ever have a personal life or ever get to go out on a date or enjoy a pleasant meal. You know, I mean, every time hardware changed, you'd have to retool and recompile the operating system, the application and software. The very reason that you do not have to recompile and tweak the code every time new hardware comes out is a testament to the purpose and reason for existence with this middle layer called firmware or the operating system. And again, it's often referred to as the universal translator. Any questions about that first concept? Everyone remembers this, right?
Sort of.
Sort of. Okay. I appreciate the candor, Tommy. Thank you. So this is from computer architecture, right? And what you're seeing is a handwritten drawing of the von Neumann model for computer hardware, right? Computer architecture. The CPU sits in the middle and it has an arithmetic logic unit. There are registers to store data temporarily, and there's a controller that helps with the sequence and execution, right, as the CPU operates. You have memory that is used to store both digital information or data and the coding statements or instructions, right? So your programming instructions are stored, and that's, you know, in computer architecture, we play up the idea that memory is a huge revolution because it's not only the tasks, but it's also the information that the tasks operate on that are stored in memory. So memory really has this duality of storage, a duality, a dynamic of its function that's kind of unique because you have instructions you have to manage, but you also have the raw information upon which the instructions operate. And at a very low machine level, that's a challenge, right? Especially when you have so many different types of memory. So there's input and output in both directions. But then if you turn the power off, all of this is gone. And what you really need is persistence. You need the ability to store information, and that's where input, output, and the hard disk comes into play. And so you have these three basic components of the von Neumann computing, you know, computer architecture. Well, why am I showing you this? Overlaid on this, and I probably need to draw a better model of this, but I would argue that one thing you can do to help this stick is for you to reference this screen right now. You can even capture this, I mean, just for convenience, capture it, right? You can draw or diagram with software tools, a cleaner looking model of this, but there are three primary functions that make an operating system work. So, and this is a point of confusion for students as they're learning about operating system principles, is that there's this idea about roles of an operating system versus its primary functions. And among the primary functions of an operating system, in order for the operating system to serve as the middle layer or universal translator, it has to be able to virtualize hardware components. And that concerns every hardware component in the entire von Neumann model. So all of these components are affected or afflicted by virtualization methods in an operating system. Does everybody understand? That's why this bracket is drawn the way it is. Everything in the von Neumann model has something to do with virtualization. But look at the second bracket, concurrence. Concurrence is a function of it's a primary, it's the second of the three primary functions of an operating system. And concurrence is another word for concurrence. Can anybody else think of another word for concurrence? What would be another word to describe concurrence? If you were working on something, go ahead.
I don't know another word to describe it, but that's concurrence mean happening all at once, same time.
Like in
Yeah.
sync?
Yes, all at once, simultaneously, at the same time. Those are phrases or words. Multitasking, right? You're juggling. When you are doing something concurrently, you're doing it at the same time. The fact that our computer systems can be used for more than one task at the same time, think about it. If your computer could only ever do one specific single task, only one at a time, how much good would your computer be? I mean, just the way we work with our smartphones is a miracle. When you think about what people do with their hands on a smartphone, they're master jugglers, right? That concurrence piece, that's all about the memory and CPU hardware components of the operating system. And on a very fundamental level, it's really important to grasp this at a very low level, kind of like the roots of the tree. Yeah. So when you're talking about the primary functions of an operating system, concurrence, or the ability to multitask, or task switch, time shift, whatever, time split, right? You have a single second, and with a CPU that does megahertz or gigahertz, you're dealing with millions or billions of cycles in a second. To us, the perception is the CPU is juggling or taking care of things simultaneously, when in point of fact, the CPU really isn't. There are multiple registers that are handling several different tasks, but each of those registers, CPU cycle process, right? That low-level process, that's independent of other instructions that are running. And the reality when you get even deeper on the hardware level is that the clock cycles and CPU are handling each of those one at a time, but because it's doing millions of those or billions of those, to the human eye, it looks like it's fluid and it's juggling all these things at once. So concurrence, there's a lot of controls and locks. We'll get into locks and semaphores quite a bit in the course. You talk about concurrence, you're talking about juggling things, and memory and CPU are the two hardware components that specifically are concerned with the overhead of concurrent operations inside the heart of an operating system. Persistence is the last piece. So the last of the three functions of an operating system, we like to call persistence. So what we're saying, when you turn off the power, the memory dies, the data disappears in memory chips after a point. What was stored in the CPU is blanked out when the power is off. But if you store it to disk, then when you boot the system, you can get back into those ones and zeros. You can load up instructions and you can load the data. Now the instructions have something to work on. So that persistence piece is all critical. And yes, there's a lot of file system and IO functions on a very low level in the operating system. And nowadays across the network, now it's been extended across the network. So it gets to be very confusing. And then people are talking about cloud and like, oh my gosh, you know, just when I thought dealing with my phone and updating its firmware was enough, the stupid Google Drive, whatever, blah, 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 those persistent issues have to do with storage, long-term storage. So the power goes off, you haven't lost anything. This piece of the operating system is the piece of the operating system that we interact with most often when we're in a filing system and we get into the disk, right? When we're into the disk and we're, everybody can still see my screen?
Yeah, still see it.
Okay. So in Windows, in computer management, we have a disk management console. Disk 0 represents, remember from computer architecture, the first digital component in any computer system is always labeled not number 1, but 0, right? So this physical disk, right, has it has logical volumes that we identify as drive letters, and we call them drives. So disk has logical drives. The logical drives have a route to the file system. We're going to go into this a whole lot more, and we're not expecting you to know this, but the root of a logical volume or drive is called slash or backslash, right? And for Windows machines, there's also a drive letter associated with that. In Linux machines, there's no drive letter associated with that. You already know this. Most of you know this. But then we have directories, and the whole directory file structure, file system, the ability to organize into containers, that business, it's all about persistence. So the third and critical function of an operating system has to do with permanent storage, what we would call non-volatile memory. Yeah. So this is volatile memory. This is non-volatile memory. There are advances in computer architecture that are blurring the lines. We have new types of disk storage that behaves like memory. It's as fast as memory, but it's non-volatile memory and it's persistent. So it's a blend of a solid state hard drive and RAM. It's wicked fast. And it's kind of changing the way certain computer systems run. Why do I mention this right now? Well, operating systems have traditionally viewed those 3 primary functions in a very distinct manner. The legacy view of it is what we just described. 3 primary functions: virtualization, concurrence, and persistence. So we virtualize different physical hard drives as a virtual hard disk, and we virtualize different. So if I look at device manager, we take the physical components and we virtualize them so that even though we have physically different devices, the virtual hard disk that presents to the operating system in the middle looks like any other hard disk, right? So that's the virtualization piece. Those 3 are traditionally I mean, this has gone on for 30 years. As long as we've had a dinosaur, right? It's as old as the dinosaurs. That's the link I want you to catch as we bring our class to a close, right? That's the legacy view of the operating system. What am I telling you? I'm telling you that what's happening right now is a revolution. And the operating system designs and operating system internal components to fully utilize this hybrid type of memory that's non-volatile, that's as fast as RAM, but as persistent as a hard disk, right? Our operating systems haven't adapted, haven't been redesigned, haven't been formulated to take the best advantage of that new hardware type. And truth be told, the von Neumann diagram represents conceptually the activities that are playing out on the hardware. But if you have a single chunk of memory and it's both your RAM and your hard disk, what efficiencies could you gain if you were to redesign an operating system from scratch? These are some of the topics and some of the higher level things we're going to explore throughout the course this fall. And on that, what I'd like to do is thank you for your patience. I apologize for the delay in start of the session. We will break up the real meaty stuff into two 30-minute segments going forward, and we will start on time. We'll do it in person, and as I said, we'll share the recordings, including this one. Before we clear today, are there any questions about the things we've covered? Our textbook, the optional textbook, which is free. So, you know, it's wisconsin.edu, WISC, that's Madison. If you just remember Remsey, OSTEP, and Wisconsin, this will come up. Operating system in 3 easy pieces. You can get along pretty well with our course with half of this. You know, half of the stuff from our course is being drawn from this. The other piece of it is coming out of here, right? So we're going to kind of straddle the fence between legacy and newer concepts. And all right. Any questions?
No question.
Not for me.
Okay. I am going to log your attendance here in Bucks Connect. I did want to mention to you that, you know, there's a requirement that has to do with financial aid, but by and large, I am going to keep track of attendance by snagging the participants list. So if you're joining in person, at certain times when I update this, I want you to tell me, oh, I'm physically in the classroom, but I'm not Zooming, right? And then when I save this, I'm going to save as, and I'll go ahead and put it in here as, you know, 16 August, right? And if you're not in the Zoom participants list, I'll say T Romero, right? So let's say that you're just joining with audio because you're on the road, Tommy, right? And so I don't see you in the participants list, but you're in the audio part of Zoom, and you're like, hey, I'm here. Then I'll add your name to this, and this is how I save the roster each time. At the end of the week, I pull the rosters and then update attendance in here so that I can keep working at UVI. Because if they don't have their financial aid preserved by the requirements of the federal government to track and monitor student attendance, then they have to, I don't know if you were aware, but did you know in cases where they find a campus is not doing that, they have to write a big check back to the government. They have to reimburse the financial aid that was dispersed to students. Ouch. I didn't know if most students were aware of why this is done and why attendance is so important. But
That makes a lot of sense now.
yeah, and people are like, what's with Bucks Connect and the Center for Student Success, man? They're calling my house. Well, that's because they're concerned. And if you are no longer attending and no longer participating in the course, what they're going to do is drop you from the roll so that they don't have to write a big fat check back to Uncle Sam, which they actually have to do. So I'll mark today because we've got it on the screen in the first place, but ordinarily I won't have this screen up. You'll only see the other one. All right, so we're done, and thank you again. We'll see you Thursday. Please remember that one of your first assignments is to pick up a copy of the textbook. When you see the assignment, I'm basically going to ask you to provide proof of purchase. Then you're going to post this by this time, 11 a.m. start of class next week, right? And then you'll see the other assignment out there about the personal, you know, your personal technology and posting some details about what you have. And I hope if I remember correctly, I think each of you are pretty well suited. I hope that's still the case. But it's been a long summer and sometimes accidents happen. There are decent laptops that you can sign out at the library if you want extras. Just saying. Okay, so I'll go ahead and sign out for now. And thanks again for joining. And we'll see you on Thursday at 11.
Have a good one.
Now that I've stopped recording, does anybody have any questions you want off the record?
No questions.
Okay.